So this video, I just want to go through a few ideas and make sure everyone has access to these ideas before Friday's validation. That is, you've done the playing the game. Now you have to answer some questions to do with probability. I just want to make sure that some of those ideas are very clear to you before you reach that second part. So let's first review the idea of tree diagrams. Now, this first example I'm going to show you is a tree diagram where we've got something like maybe tossing a coin. So we've got a 50-50 chance here. Now, when I take my first toss, I can either get a head or a tail. And these are evenly weighted, so we've got a 50-50 chance, or 1 in 2, one chance out of 2, because we've got a head out of a possible head or a tail outside of a possible head or a tail. So they're evenly split. So to get our head, we've got 50%, which can be written as 1 on 2, which can be written as 0.5. All of these answers are the same. And if you write 50%, a half, or 0.5, we'll accept any of those. Heads or tails, 50-50. Now, if you were tossing 2 coins, then we'd have to keep going. We'd have to say, well, what are my chances of from here, now tossing a coin again and getting, already got a head, so I can get heads, or following this tree, I've got a head, so then head tail. How do we work out that chance? Well, we've already got our 50% here, or our half. These are evenly weighted, so I've now got another half chance or a half chance. What does that make altogether? In order to make the probability of head, I just follow along these trees branches, and I multiply the outcomes together. So it would be a half times a half, and if you need to, use a calculator, and you get a quarter. So my chance of getting a head and a head when I toss two coins in the air is 1 in 4, otherwise known as 0.25 or 25%. They all mean the same thing. 1 in 4. And if I do it for head tail, this is a T, it's a terrible T, sorry about that. I go 1/2 times a half. Again, I'd get a quarter. If I go down here and I've already got a tail, then again when I toss my second coin, I can get a head or a tail. And I'm methodical. I always, in this case, put the heads up and the tails down. Just helps me track what's happening. Again, they've got a 50% chance, or a half and a half. So in order to find tails heads, I'd go a half times a half, which is again a quarter. And to find the last one, tails, I would go a half times a half, and I'd get a quarter. Now look, each time I complete a column, that is, I've done the 2 branches for the first column, now I've done the 1, 2, 3, 4 branches to make the next column. If I add all the answers here together, that is, if I take a quarter and a quarter and a quarter and a quarter and I add them all together, I can check that I've got the right thing, because each column should always add up to 1. Just like 0.5 and 0.5, or a half and a half added to 1, a quarter should add to 1. Now we're going to pretend that we've actually tossed 3 coins, so we're going to complete this tree diagram. A half, and then we've got 2 heads already. If I just follow this branch along, head, and then head. So up is head, so head, and a head would be head, and then tail would be heads, tails. We've already got our 2 heads, we're then going tails. Our next branch down was heads, tails, so heads, tails, then head would be heads, tails, then head. Heads, tails, then tails would be heads, tails. And I just keep going down, tails, heads, tails, heads, tails. And just try and be methodical as you go. And the last one will be tails, going up, heads, tails, heads, tails, tails. So the only one with 3 tails would be the very bottom. Now to work out the probabilities, I just start at the very beginning, and multiply along each branch. And again, this last branch hasn't changed, it's still a half or 50%. So I'd go a half times a half times a half, which will give me 1 on 8. And because these are evenly weighted, we've always got a half on each branch, a half, a half, a half. All of them are going to have a 1 on 8 chance of happening. That's when they're evenly weighted. Now, the kinds of questions you might be asked here are, what are my chances of getting all tails? And we can see down the bottom, we can just read it off. My chances of getting 3 tails is 1 on 8, which if you get your calculator would be the same as 0.125 or 12.5%. All we do to do that is 1 divided by 8 equals, and then see what our calculator tells us. Another common question is, what is my chance of getting 2 heads? Well, this one's a little bit trickier because we need to go along and see which outcomes have 2 heads. This one's got 2 heads. This one's got 2 heads. This one's got 2 heads. And if I look down here, that one's got 2 heads. So I've got 3 different chances. And I just go, all right, well, I've got 1 in 8, and I've got 1 in 8, and I've got 1 in 8. So my chance of getting 2 heads is 3 on 8, because I just add those outcomes together. There are other types of questions, but I'm not going to show you absolutely everything. That would defeat the purpose. So that's how we make our tree diagram, and just read the question carefully. What is it asking me? And if it's asking me for more than one outcome, then just add those outcomes together. Here is a trickier tree diagram, if it'll let me swap. Oh dear, I'm clicking the wrong thing. There we go. All right. This one is called a weighted tree diagram. Now, an example I might give is maybe you've got what's known as a 4-sided dice, and they look something like this. And when you roll them, it always lands with a point up. Sorry about that. So there's kind of that dotty line is what's happening behind it. You can't see that. So it's like a triangle with triangle sides, and we call it a 4-sided dice. Now, what if, might be easier if I just go, well, what if it was a spinner with 4 sides? 1, 2, 3, 4. You know what? Bother that. I'm going to make it even uglier and say, sorry about that. What if I just say we make a spinner with 5 sides? That'll make it a bit nicer. Okay, a spinner with 1, 2, 3, 4, 5 sides. Toothpick in the middle. You spin it around, and you can get 5 different outcomes. Maybe 1, 2 of them are blue, and 3 of them are red. So when you spin this spinner around, you can either get a blue or a red. So my chance of getting a blue then, my chance of getting a blue is 2 on 5. My chance of getting a red is 3 on 5. And that won't change if we're just looking for blue or red, and we're only spinning it once, fine. Then that spinning it once, we get 2 on 5 chance of getting a blue, 3 on 5 chance of getting a red, fine. And you can change it into a decimal if you want. That would be 0.4, that would be 0.6, no big deal. If I wanted to get blue, blue, then I'd have to get blue on the first one and blue on the second one. To work out my chances to get blue, blue, I'd have to get 2 on 5, and then 2 on 5 again. So 2 on 5 times 2 on 5 makes 4 on 25, and again, use your calculator, just multiply along the branches. To get blue, then red, to get blue, then red, blue, we've already got, then red, well, I've got a 2 on 5, and then a 3 on 5. I multiply those together and I get 6 on 25. And you just work your way through, making sure that you've gone, if I've gone red and then I've gone blue, then that would be red, then blue. My chances would be 3 on 5, but then to get red is 2 on 5. I multiply those together. 3 on 5, 2 on 5, 6 on 25. And then lastly, red, red would be going down, then down. So that would be 3 on 5 and 3 on 5, which would be red, red, or 9 on 25. Again, this should add up to one whole. 4 plus 6 makes 10. 10 plus 6 makes 16. 16 plus 9. 25 out of 25. We know that's one whole. It's one whole, so it must be correct. And lastly, if we spun it 3 times, we'd get blue, 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 red. We'd get blue, red, blue, blue, red, blue, and then blue, red, red. Some of you have noticed this time I'm going blue is always up, red is always down, blue is always up, red is always down. So in this case, if I've got red, blue, blue is always up, so I go red, blue, blue, and then red, blue, red. Then of course red, red, blue, red, red, red. That way, by labeling it, I can check what is my chance of getting a blue. Well, coming right back to the beginning, my chance of getting a blue is 2 on 5 by itself. So my chance of getting blue, blue, blue must be 2 on 5 times 2 on 5 times 2 on 5, which, if you get your calculator, will be 8 on 125. And all you do to work out each of these probabilities is follow the branches along and multiply each branch's chance by the next branch along. I'm not going to do that for you. You can try that out, and if you want to, you can check with your teacher to see if you've got the right idea. Check before Friday. Okay. They are weighted and unweighted tree diagrams. And of course then you might be asked questions like, what are my chances of getting blue, blue, blue? And you would say 8 on 25. What are my chances of getting red, red, red? Well, that would be 3 on 5 times 3 on 5 times 3 on 5. So it would be 27 on 125. That's what your calculator does for you. Let the calculator do it for you. And if you said, got asked, say, what's my chance of getting exactly one red? What's my chance of getting exactly one red? I'd just go through an underline. There's one red. There's one red. And is there not another one that has just one red? Red, blue, blue, there he is, yes. And so I just work out those chances by going across and going 3 on 5, 2 on 5. What was that? 2 on 5, 3 times 2 times 2, which is 12 on 125. And I'd work out, and you'd find that each of those was 12 on 125. And so what is my chance of getting exactly one red? Well, I just add those together, and so that would be 12 plus 12 plus 12, which is 36 on 125. So that's how we answer questions using a weighted tree diagram. Okie doke. Now, this one is called a Venn diagram. You might want to pause, just make sure you understand tree diagrams. This is a weighted tree diagram. 26 people played a game where they had to shoot a can off a bucket. Sounds like a fun game. Okay. They each played the game twice. 16 people won the first game. 13 people won the second game. 8 people won neither game. Well, that seems a bit crazy because 16 and 13 is 29, plus another 8, that's 37. That's way more than we've got. We've only got 26 people. So how on earth do we put that information into a tree diagram? Into a, come on brain, into a, what do you call it, a Venn diagram. That's what these are called, these circly things. Well, here's game A, here's game B. We want to try and get it so that game A and game B have the information about people that won game A and B. And then this space on the outside is for people who won neither. So let's do that first. 8 people won neither game. So out of that 26, how much do we have left over to play with? If we had 8 people winning either game, we've only got 18 left to play with. Well, 16 and 13 together, well, that's more than 18, way more. So 16 and 13 makes 29. Let's see. If I went 29 minus 18, what do I get? I get 11. I hope. Yeah, that sounds about right. 11 people must have won both games. And here we have this overlap where 11 people can exist in both A and B. Now if there's 11 people in here, and we know that 16 won game A, then 11 plus the leftover must make up game A. So 11 plus 5 must make up game A. So now within the whole of game A, we've got 16 people winning game A. Game B, we've already got 11 people winning both games, game A and B, but game B is supposed to add up to 13, so I can put another 2 in there. Now, have we satisfied this? Do we have 26 people altogether? 5 plus 11 is 16. 16 plus 2 is 18. 18 plus 8 is 26. We've got the right number of people. We've got 16 winning game A and 13 winning game B. Alright, be methodical and have fun. Thanks, girls.